Chapter 4, Section 7 is on triangle congruence again, but this time we're going to do something called CPCTC. So by the end of this lesson, you should be able to use that to prove parts of congruent triangles are congruent. So CPCTC stands for corresponding parts of congruent triangles are congruent. So remember before we had to prove that all 6 parts of a triangle were congruent to say that the two triangles were congruent. Now we don't have to do all 6 parts, we only have to do 3, and sometimes 2 if we're using the hypotenuse length thing. So once we prove that triangles are congruent, we can then go back and say that all of the corresponding parts of this triangle are congruent, even if they weren't a part of the original thing that we used. So we are going to prove triangles are congruent now, and then prove different parts are congruent. And we know they're congruent because the congruent triangles and this theorem that says corresponding parts of congruent triangles have to be congruent as well. So here's a simple example. Landscape architect sets up the triangles as shown in the figure to find the distance JK across a pond. What is JK? So we can see from this that M to L is 30 feet and L to K is 30 feet, and that J to L and L to N are both 19. And then we know by vertical angles that JLK and MLN have to be congruent. So we know JL is congruent to LN. That's kind of given to us. And we know ML is congruent to LK. And then we know angle JLK has to be congruent to angle MLN because of vertical angles. So right now we have side angle side that will prove that these two triangles are congruent, that JLK is congruent to NLM from side angle side. So now that we have that these two triangles are congruent, we can use CPCTC to prove any other length is congruent. So this MN has to be congruent to JK. And because of that, we know that JK is 41 feet. Now chances are that's what you got in your head just by looking at the picture, but we need to prove why we can do that, and all of those reasons there help us do that. So let's do another proof. Given that AB is congruent to DC, so this distance and this distance are congruent, we got our statements, our reasons, and then they also tell us that A to B to C, so this angle here is congruent from D to C to B, so this angle here. We need to somehow prove that A and D, angles A and D are congruent. So when I look at this, I see several different triangles here. We have these triangles in here, but then we also have these big triangles right here. This one and then this one overlaps on top of it this way. So since they don't give us any more information, we can stop and think about what we know. Vertical angles tell us that these two have to be congruent, but then that gives us a side and an angle that we can use to prove that those two triangles are congruent. The other thing you can do is say, look at these bigger triangles, and you know this length has to be congruent because of the reflexive property. Either way, we can use that to prove that there's some triangle congruence there. I'm going to use the reflexive property because that one makes a little more sense to me. So I'm going to write that BC is congruent to BC because of the reflexive property of congruence. So now I know that this triangle here, ABC, is congruent to triangle DCB. And the reason I know that is because of side, angle, side. Now that I know those two triangles are congruent, every part of those triangles has to be congruent as well. So I know this angle here has to be congruent to that angle there. So angle A has to be congruent to angle D because of CPCTC. Congruent parts of congruent triangles are congruent. Let's do another one. So we have our statements, reasons. So the first thing they tell us is that YW bisects XZ. So if we look at our picture, YW bisects XZ, that means that we know we have two congruent parts there. So XW has to be congruent to WZ. It's definition of bisect. And then the next thing they tell us is that XY is congruent to YZ. So in our picture, XY and YZ. So it's looking here like they're just giving us enough information to find some sides. So remember, in order to do that, we need all three sides to be congruent. So they happen to have an overlapper right here. So we can say that YW is congruent to YW because of the reflexive property. And now we know these two triangles are congruent. So triangle YXW is congruent to triangle YZW based on side, side, side. So now that we know that, we can go back and prove that any parts of these triangles are congruent. So I want to prove that XYW, this one here, is congruent to ZYW. And we can do that based on CPCTC. Alright, so let's try this one. We have our statements and our reasons column. So the first thing they tell us is that NO is parallel to MP. So if we look on our picture, NO is parallel to MP. Sometimes it helps to think of these as actual lines that go on forever and ever. And because they're parallel, we know there's something special about this MO that crosses here. That's our transversal. So from that, we know that we have alternate interior angles that are equal. So we know we can say that angle NMO is congruent to angle POM. Alternate interior angles. This one and this one. We can say that the other ones are equal, but if we're just trying to prove that these triangles are congruent, we don't need all of that. So then we can say what else they gave us, that angle N and angle P are congruent. So now I have two angles, and we need to find a side to make sure that our triangles are congruent. So remember, this one's shared, so MO is congruent to MO by the reflexive property. So now we can prove that these triangles are congruent. So we're going to say that triangle MNO is congruent to triangle OPM, and this is because of angle, angle, side. We have enough for two angles and then a side. And now once these triangles are congruent, we can say that everything else is congruent. So we know that these angles are congruent here, these sides are congruent, and these sides are congruent. Now remember what we're trying to prove is we're trying to prove that these other two lines, NM and OP, are parallel to each other. So in order to make that happen, this MO is still our transversal. I got to prove that I have alternate interior angles that are equal. So I want to prove that this angle and this angle are congruent. So because I know those triangles are congruent, sorry, not this one in here, this blue one. Because I know those triangles are congruent, I can say that angle NMO is congruent to angle POM because of CPCTC. And then because these angles are equal, we can say that line MN is parallel to line OP because of the converse of alternate interior angle theorem. So that is it. You should be able to use CPCTC to prove parts of congruent triangles are congruent. So it's basically one more step than all the other proofs that we were doing before. We'll practice this lots and lots in class. So have a good weekend, and I will answer any questions you have on Monday.